All right. So there we go. So there's our question. How do we actually solve that? It's asking what is 6? Oh, wait, I got to. One more small technical issue. Got to get my little pencil thing locked in. So it's asking what is 6? I'll put it back up in a second. But what is 6 to the 2 power? What does it mean to put a little number in the upper right-hand corner of something? I bet you know.
Using it to an exponent?
Yeah, it's called exponent. That's the name.
Multiply.
And it means multiplied by itself that many times, doesn't it? See, we're back up here on the screen. And we'll be able to solve. Yes, all right, so now it's working. So 6, there we go. My pencil's working, and everything's actually working. Only 1 hour into class. All right, 6 to the 2 power. So what does that mean? Yeah, you all know, huh? It means 6 times 6. It means that number multiplied by itself that many times. Little numbers in the upper right-hand corner called exponents, powers. Exactly right. And so which of these, I'm looking at those words, which one of those is that right? 6.
B?
Yeah, it is B, isn't it? It'd be B there. 6 squared, or 6 to the 2nd power. So that's what it actually means. Can you all see that okay? And so that's all we need for question number 1. I'm going to move on to question number 2, if you've got that down. So your question 1 will be the same. Like I said, you can do your work. So write it. If you had your laptop or your cell phone, you could get access and do that question right as we move along.
Would it give us the option to correct it if we...
Oh, yeah. The way it works, yeah, I'm glad you brought that up. It's not, for multiple choice, it might only give you 1 or 2 options. If you get it wrong, 1 or 2 or 3 times, depends on the thing. It'll mark it wrong, gives you 1, 2, or 3 attempts, depending on the type of question. Usually 3. Usually gives you 3, like baseball. 3 pitches, 3 strikes, you're out. But then if you can make a new one. Let me show you. Let me actually answer wrongly. Let me go back. Oh, yeah. Let me also say, what I'm doing when I go back and forth between these programs, I'm going to, this is Docere, created with Docere. It's saving my lecture. So if you miss class, or just want to look back to what happened in class, this will be on YouTube right after class. So this whole lecture will be on YouTube right after class with the video and the writing and everything. That's let me find right where you would go to do that. To find the lecture is available. Because I don't want you to miss out if you have to miss class. YouTube, you go to youtube.com. and search for my name. I'm really famous on YouTube now. Sure, I'm getting my points, or what is it called? Likes, my likes. I'm kidding, I'm not up with all that. In fact, I just started with all this. I feel like Mr. Tech Guy, but I am not, as you've seen. My kids actually had to help me get this set up. I copied this from a physics teacher, Mr. Balo, and he put me onto the whole iPad, because that way you can save your lectures, and it's just helpful to students. But anyway. So my kids at the start of the spring semester, I said, kids, I need to get on YouTube, my teenagers. And then they're like, oh, Dad, we know how to do that. We'll get you set up. So anyway, so now I've got my own little YouTube thing. So just search Brett Heron and go for our class, Math 255. And all the lectures will be there. So and that'll come right after class. I'll actually ship it right after class. It's really convenient. It's out there. So you can look back. If you missed class or if you just forgot what happened, you want to go back, it's all there. All right, so what does it mean to be r to the 5th power? It means 5 r's multiplying together. That's all they want. And as you see, you don't even have to show the times. If you just put the 5 r's next to each other, that means multiply already when there's no symbol in between. All right, you know all that. I'll get moving. And then the Docere here that records everything. All right, so there's the question. It's recording it now. So 2z to the, if you can see here, I'll make it a little bigger. 2z. So give it a try. Go ahead and work that out. Let me give you a second, and then I'll finish it. See if you know on your own paper what that means. Write out what you think that means, and I'll finish it on the screen. So 2z to the 3rd power like that. So what is the 3, little number in the upper right-hand corner of the power? What does it mean? Well, it means 3 of them, right? Now, is it only 3 of the z's? It's the whole thing, huh? Because it's on the whole thing. In other words, it means 2z, and you don't need the parentheses anymore. Basically, whenever something from the outside of a parenthesis acts on it, then you can drop the parentheses. You know what I mean? That 3 just acted on the parentheses. So drop them, right? So you can drop off the parentheses, 2z, 2z, 2z. That's fine. You can leave it that way. That's totally fine. And that would just be our answer. I'll say or, like on a test, it would be fine if you wanted to rearrange those and put all the 2's first and then the z's. And then that is 8z cubed, isn't it? But they said do not simplify. So they don't really, on this particular problem, they don't want me to do all that. They want me just to leave it here. But I'm just letting you know, at different times on different problems, we might go all the way down to here. Those are all 3 of these are different versions of the same thing, aren't they? You know you can rearrange the order of multiplied items, like I rearranged the 2's and the z's. You know that from numbers, don't you? Think about like 2 times 3. What does that equal? 6. Is that any different than 3 times 2? No. So like you can switch the order of multiplication, and that's all I'm doing with these 2's and z's, is I'm just reordering the order of their multiplication, huh? So that's always fine to do, like you already know with numbers. A letter is just a number we don't currently know, huh? So whatever rule is true for numbers is true for letters. So yeah, so these are all the same. How do you know which one? You'll know on the test it won't be a problem because it'll be multiple choice and you'll see the answer they want. You'll see this. They won't have both these things. They won't have this and that on a multiple choice test. They'll just have one of them, and so you grab the one they have. Okay. Okay, so T times T times C. So now they're going the other way. They want me to go from the expanded back to the power language, right? So what would that be? T and the little 3 in the upper right-hand corner. Yeah, that's all they want me to say there. I'm going to make sure I'm comfortable with the power language. All right, so I'll keep going back and forth. If it's too fast for you, easiest ones in class, because I don't have time for the hard ones, I'll let you do that in your homework. I'm totally kidding. I try to do the hard ones in class so that when you go home, you've seen the worst of it, and then I'll skip the easier ones. All right, so there we go, 6 plus 9. So go ahead and work that. Let me let you do that first, and then I'll feel free to use your calculator if you're rusty on some of those times tables and things, and I'll finish it up. Okay, let me do it wrong at first, and I bet a lot of you already know. You probably know the trick on this one. This is wrong to first add, huh? Like that. 6 plus 9 would be 15 times 4 would be 60. That's not right. Do you remember that? Why? What's wrong with that?
It's the multiplication.
Multiplication. You have to do the multiplication first. Yeah. Remember, yeah, this is order of operations. What is the order of operations? PEMDAS. Yeah, do you remember that? Please excuse my dear Aunt Sally is the memory device, or however you want to say that. PEMDAS. P stands for parentheses. E stands for exponents, like powers. M and D stands for multiply and divide. And A and S?
Addition and subtraction.
Adding and subtracting. Yeah, that's the order of operations. So math isn't just left to right. It's the order of operations. So, in other words, the multiplying has to be done before the adding, because multiplying is higher than adding in the order of operations. Yeah, they're testing to see if you know that. So you got it. So the correct answer then would be first do the 4 times 9, which would be 36, and then add. So 42 is the real answer on that. Do you remember that? The order of operations, multiplying first. So, as far as the PEMDAS and remembering that all perfectly, really you don't have to. It's kind of funny, I'm a math teacher saying don't remember the rules. But really, the main thing to remember that will really help you is just remember adding, subtracting is last. That's the only thing that usually fools people. The rest of it pretty much comes natural, as I've seen over the years. Students know parentheses are first, and they know the rest. The only thing that trips people up is they sometimes forget that adding, subtracting is the last and the lowest, and they'll do that too early. So just remember that. Adding, it's the first thing you ever learned in math as a kid, right, was to add and subtract. That's the lowest operation. That's the last operation. Do anything else first. Adding, subtracting is last. If you just remember that, you'll be fine. All right. Well, you stop me if you want. All right, so try that one. Can you all read that? 19 plus 2 times 3 squared. So go ahead. Like I said, you can use calculators for everything. So we're going to go till 9 o'clock. That clock's an hour off, and we'll take our break is the plan. So 2 hours, take a 10-minute break, and then 2 hours. And stop 10 minutes early. So got about 40 more minutes till our break. Okay, so what do I do first? I can't add. So just the main thing to remember, adding is going to come last, huh? Everything else I think you'll do right. If you just remember adding, subtracting is last. So what do I do first then? Yeah, 3 squared, huh? What's 3 squared?
9.
Yeah, because it's 3 times 3. Not 3 plus 3, huh? 3 times 3, it's 9. Bring everything else down. And remember, adding's last. So what am I going to do next?
Multiply 2 times 9.
Yeah, 2 times 9. And now, adding last at 37?
Yeah.
37. 37. Good on that? You remember that kind of stuff? All right. All right, let's try that one. 4 squared minus 50. All right, try that one. What do you do first? Yeah, that exponent in the parentheses there, right? And that's what, 16? Good like that first. First do that power. And next, no, that subtraction will come last, huh? Because adding, subtracting is last. So next we'll do this multiplication. By the way, did you notice the parentheses did not disappear yet? Why not? What did I say about when parentheses disappear? When something from the outside of the parenthesis goes in. That's... You know, I was thinking about it like water with a floodgate, right? We've had a lot of rain this year finally. So our dams are full of water. So when the wall comes down, the water goes in. Same kind of thing with parentheses in math. That works. When something from the when the parenthesis walls drop, is when something from the outside goes in. Kind of think about it that way. So far, that 4 to the 2 power, that was all inside the dam. Nothing from the outside. So the parentheses, the walls are still up, right? Now I will drop the walls and something from the outside will go in. 4 times 16. That's when you drop the walls. Be what, 64? Minus 50. And then last step was at 14. There we go. Subtraction last. Drop parentheses and something from the outside goes in. All right. The hard one's at the end. So, all right. Try that one. So 200 minus 60. Plus 3 times 2 to the third plus 23. Okay, so remember, adding, subtracting is last. Do everything else first. So where do we go first? Yeah, that power right there. 2 to the third, what's that, 8? Because, again, it's multiply, huh? It's 2 times 2 is 4, times 2 is 8. Bring everything else down there. Okay, next. Multiplication, yeah, because we're just saving, adding, subtracting for last. Huh? So we do the multiplication. 3 times 8 there, be 24. And then it's just all add. Just use a calculator if you want, or do it by hand. Just all adding, subtracting. 200 minus 60, what's that? 140. And 24 and 23, I don't know. I'll do it vertically maybe. Oops, I kind of moved the order. Doesn't matter. Is that 187? 187. We good with all that? Questions? All is well? All right. Well, I'll keep moving. Okay, so 10 plus 5 squared over 6 squared minus 1 squared. All right, give that a try. So we do the power stuff first, huh? Now 1 squared is just 1, huh? Because it's just 1 times 1. So far, so good. Okay, now we can do the adding, subtracting. What's that? 35. Oh, it's 35 over 35. It's just 1. That whole thing's just a big this is just a big fancy way to say 1. That's what that means.
Why wouldn't you add and subtract exponents? Negative 1 second, or 1 over 2. Sorry, negative 1 squared minus. Sorry, 5 squared minus 1 squared, and then work it out like that. Does that make any sense?
So you're talking about this part of it, the 5 squared over the 1 squared?
Yeah. Why wouldn't you cancel out the 1 squared completely by subtracting it from the 5 squared?
Let me see. Just like a 5 minus 1 be 4 squared, like that, you mean?
Yeah.
Yeah, okay, it's a good question. We can't subtract. I know what you're thinking of. You're thinking of the rule where we subtract powers, but it goes like this. It's like if you have x to the 5th, say, over x to the 2nd. We'll get to that rule, I don't know when, real quick. Today, tomorrow, next day. And yeah, that's when you subtract powers. But they have to have the same bases. So in other words, if these were both 5s, here's what it would be. If those were both 5s, and this one was like the 3rd power, and this one was like the 1st, then we could subtract them and be 5 to the 2nd. That's what you're thinking of. It's that rule where the bases are the same, you can subtract powers. But in this case, we had different bases. The 5 and the 1 are actually different bases, so we can't do that. Yeah, we're coming to that rule. You're remembering things right. That rule will come. But for now, it's just the numbers, so we just work out the numbers. All right, good. Let's do that one. We're almost done with this section. Okay, so x squared plus 3y squared over 3x squared plus 4. All right, and we're supposed to plug in x is 2 and y is 2. So you know how to plug into formulas, right? You put parentheses around the numbers that you're plugging in, and you plug them in where the letters are. They take the place of the letters. So in other words, this will become, when you plug in, this 2 will go in right there, and the other 2 will go in right there, and this 2 will go in right there. So it'd be parenthesis 2 squared plus 3 parenthesis 2 squared over 3 parenthesis 2 squared plus 4. Everybody see what I did there? So when, what's that?
You plugged them in. I didn't see that side one.
Yeah. Yeah, so I plug them in like that. So put parentheses around the numbers you plug in and put them in the place of the x's and the y's. I plug into plus. Now, can you work it out from there? Do those powers first. Adding, subtracting last. So 2 squared is 4. 4. A lot of 4s. So I did the powers, right? All those 2 squareds become 4. And now, remember, do the adding last. So 3 times 4 is 12. 3 times 4 is 12. Oh, it's going to be 1 again?
Yeah.
It's a big 1. 16 over 16 becomes 1. Question?
So I got the same thing that I just got, 2 to the second power, and then combined it with the parenthesis 2 to the second power next to the 3, so it becomes 2 to the fourth power plus 3. That's the same thing, right?
So you said you took, in the top you mean?
Yeah.
You made that 3 times 2 to the fourth power?
Yeah.
Oh, no, actually you can't.
Or not that, no. I combined, what are they called? The exponents?
Okay, that's only when they're times.
Okay.
I hear what you're saying. Like when you have x squared times x to the third,
Yeah.
that'll be x to the fifth.
Yeah.
Notice that's when they're timesed in the middle. We have adding, so we can't combine those.
Okay.
Yeah, so you don't have to do any fancy operations. You guys don't know all these rules. We'll get there. We'll get there when we'll start doing the rules with all the letters and stuff pretty soon. For these ones, just work out the numbers. Just do just do the 2 squared all by itself and get a 4, and then, yeah. For right now, you don't need to do any fancy math rules of combining stuff. We will get there pretty soon. Good. Other questions on that one? It might have kind of luckily worked out to be the same number anyway, but it won't always, so be careful. Good there. All right. Are word problems your favorites? I'm just kidding. I know word problems are never popular. Sadie bought a sofa, paying $200 down, and $32 per month for 12 months. Find the cost. I bet you can do that. Oh, they don't even want the answer, huh? They just want me to say which one of those is the way you would work that out. Let me give everybody a chance. Don't say it out loud. Give everybody just a chance, and then we'll answer it together in a second. Look at those A, B, C, D, E, F, G options. So they don't even want the final answer. They just want us to, like, how you would work it out, figure out which way is correct. So what do you think? Which of those letters is the right way to figure that out? Yeah, it looks like E. 200 add 32 12 times, because it's $32 per month for 12 months, huh? So it's 32 times 12, and then you got to add the 200 down for the sofa. Does that make sense there? That'll be correct. Okay, that's our first section. Let's move on. All got that down? All right, a scuba diver ascending 23 feet is represented by 23. How do you represent a scuba diver descending? So first off, what are those words? Ascending, descending. What is... I guess it's almost like a vocabulary test or something. What's ascending, and how's that different than descending?
Going up and down?
Yeah, up, right, up and down, exactly. So yeah, ascending, the scuba diver was going back up towards the surface, right? Ascending is going up, descending is going down. So if he ascends 23, that's a positive 23. So what do you think descending 5 would be represented by?
Negative.
Yeah, they just want you to say it's negative because it's going down. That's all they're getting at. That's what this section, that's what, whenever they say integers in a math class, that means they're going to use negatives. Because integers include the negatives. That's basically what the buzzword. You just want to think, oh, they mean we're going to use negatives now. So negative 5, that's all. So they're going to just start pointing out to real life things like that are negative, like when you're in debt, right? That's negative amount of money. And when the temperature's below 0, those are negative temperatures. They're just going to point out to real life negative things. So there's one there. So they said, okay, put -4, 0, and 5 on the number line. So -4 is right here. 0 is right here, and positive 5 is right there. They just want you to click on those 3 spots. In fact, I'll go back and do the question actually with you. I think we just literally click on those 3 spots and we're done. Let's go back and see. Okay, so the negative, the opposite of that. So they want me to do the negative of that. See how I did the negative in the front? The negative of the absolute value of negative 91. Those lines mean absolute value, those straight lines. Let me write that. Absolute value symbols. Okay, and what do you do with absolute value symbols? They turn the number inside positive, then they vanish. Yeah, so what the absolute value symbols do is they make the thing inside positive and then they vanish. So, let me do that. So let's do that. So those absolute value lines right here, so these 2 lines, they will make that just the minus inside. They won't touch the minus that's in the front. They'll just make the minus that's in between them, the minus 91 will make that vanish. So they'll cancel out that minus sign and then they'll leave, but this minus is still there. Does that make sense what happened? So the one in the very front, he's not canceled by the absolute value signs. They just do the one between them. They get rid of the minus between them, and then they vanish. The one that's in the front, still there, he comes down. So the final answer is negative 91. Just one minus. The one between was canceled by the absolute value bars. That's different than parentheses, huh? Parentheses would not do that. Parentheses would just leave the minus there. But absolute value straight lines, they get rid of the minus in between and then vanish. But the minus in the front stays to the end. So the final answer is negative 91. Is that good? Now you might think, well, wait, Mr. Aaron, what about the rule 2 negatives make a positive? You guys know that rule, huh? The 2 negatives make a positive. Yeah, that's what we would have done if these were just parentheses. I totally would have done that. I would, 2 minuses, make them plus. It's just a positive 91. I would have done that. But because of the straight absolute value bars, I can't let those 2 negatives hit each other because the absolute values get rid of the one inside. That's why we weren't able to do that other rule of 2 negatives make a positive, because the one inside was eliminated by the bars. Make sense, those different rules? Yeah?
Does the absolute do the inverse as well, make a number negative if it is a positive?
Good question, no. If there's no negative inside, it just leaves them alone and vanishes. Yeah, so it only makes things positive. It only makes things positive. Isn't that kind of a weird rule? Like, why do we have this thing in math that, like, makes things positive?
There was the video I saw online just described it as the absolute value just being the difference between the number and 0, like how far away is from 0 on the number.
Yeah.
That kind of made more sense for me.
Yeah, that's good. Yeah, good answer. It's just how far from 0, huh? Like, so negative 3 is 3 away from 0. Yeah, that's a good way to do it. And you know where that is in the real, you know math. Math is, all math is made up. Math is totally made up. I don't know if you know that. Math is made up, but it's made up to describe things in the real world, right? If you're, maybe it's a good chance. Let me do 1 minute of math philosophy. So again, let me ask that question: is math itself, just math itself, real? And the answer is actually no. Math is not real. It's made up, as I was just saying. Does that seem funny? I mean, like, well, what are we doing here? Class over, right? I mean, this is just, I'm not supposed to, don't tell the dean I told you. I'm not supposed to let this secret out. Math is just made up, right? But it is. Think about it, right? What if I told you guys on the way to class today, I saw 3. There it was. I was running from my car to class, and there was 3. You would think, what do you mean you saw 3, Mr. Aaron? You saw 3 people or 3 cars? No, I didn't see 3 people or 3 cars, not 3 objects. I just saw 3. You would think, what do you mean? You saw like the number 3 spray painted on the wall, or the number 3 written? No, I didn't see the number 3 written anywhere. I didn't see 3 objects of any kind. I just saw 3. You would go, you're ready for the padded room, Mr. Herron. You can't see 3. And you're right, you can't. It's just in your head, right? You can't taste, touch, or smell math, can you? It's not in the real world, but, so it's made up. I know the concept of threeness, and you know the concept of threeness, so that when I do see something in the real world involving threeness, I can talk to you about it, right? If I saw 3 cars in a head-on collision at Blackstone and McKinley, and I came to class and say, hey guys, I saw 3 cars in a head-on collision out in Blackstone and McKinley, you would know what I'm talking about. And I'm describing something in the real world using a made-up system called math, right? So that's what math is. Let's make sure we put math in its right spot in the real world. It's made up to describe things that are real, right? We use it so commonly, we don't think of it as a made-up system describing things that are real. But math is just part of the language. Really, math is a language, right? I remember reading, realizing how significant language is, and including math, and that we don't think of it. I remember reading this one book one time where this missionary went to this island, and they didn't have a language written down. And he and his wife were on that island, and his wife was back at the main hut or whatever, and he would need supplies. He was out building something with the natives of the island, and he would take a piece of wood, and he would write some instructions on the wood to his wife, like a little letter. Please give me 3 boards and the 2 hammers and the screwdriver, whatever. And he would hand it to one of the natives to run back to his wife, and show the wife, and she would give him the supplies, and they would run it back to the missionary. They were always shocked because they'd never seen written language to that point. And they were shocked that he would scribble on a board, hand it to them, they would run back and show it to the wife, and the wife would look at the scribbles and know just what they called it, the talking board. That's what they called it. Just to see the shock that symbols can communicate. Well, that's exactly what math is, huh? Math is symbols that communicate real life things to us. So anyway, so that's what math is. It's not real. Absolute value is one of those things we made up. We made up to describe things that are real. Now what? What in the real world do we ever do where we get rid of minus signs? Do you do that? Yes, you do. Think about it for a second. You don't think, I'm getting rid of the minus sign, but you do it, right? Here's where. What if I was going to tell you, I'm going to go on, we have families. Sometimes we go north, up to Eureka, California, which is 250, 300 miles north, near the top of California. My wife's one sister's up there, and my wife's other sister's at the bottom. They cover California. Southern California, South Orange County. So that's 250 miles south of us, right? But if I was to say how far away is the sister down south, I wouldn't say negative 250, would I? If you guys ask me, how far away is it? I go negative 250, you give me a weird look. What do you mean negative 250? Well, it's south, so it's negative. No, we don't talk that way, right? What do? We just get rid of the minus sign. All distances, in the common way we communicate, all distances are what? Positive. We just say a positive number. What are we doing? Getting rid of the minus sign. We're doing absolute value. We don't think, I know you don't think that way, oh, it's negative, but I'll get rid of it. No, you don't think that, but that's what you're actually doing. That's what absolute value is made up for. The main thing it's used for is describing real life, physics, things like that. You do distance problems, you need absolute value to get rid of the minus, because the way we communicate about distance is positive only. So anyway, there we go. There's my math spiel in the real world. It's used to describe things that are real. So just get rid of the minus sign in the middle. Yes. Let's try this one. Okay, so like that. All right, so you give it a try. So do the rule that I was telling you for absolute values. So what do absolute values do? They get rid of the minus that's between them, but there is no minus between them, huh? There's no minus in between them. And then they vanish. So they're just going to vanish, and this minus will come down, and the answer is minus 64. Oops, that's an arrow. So this time there was nothing for them to get rid of. So they vanish. So they either get rid of the minus between them, or there is no minus between them, and then they vanish. So they always leave. Make sure they're gone when you're done. They always leave after they do their job or do nothing really, and then vanish. The minus in the outside stays though, right? What if the problem had been this? Then they would get rid of it and vanish, and it would be regular 64, huh? Yeah.
So you would drop down the negative sign?
Yeah, so anything in the front stays there. Exactly right. And that's what we did in the last one, right? Let me look back at the last one. See the minus in the front of the last one? Stayed there also. So the minuses in the front stay. The minus inside, if there is one, gets canceled out, and the bars vanish. Same thing here, right? So the bars vanished. There was no minus on the inside to get rid of. The minus on the outside stayed. Good?
Can you go back to the previous problem for a second?
Yeah.
If we had to show our work, let's say for another instructor,
Yeah.
the actual question says just absolute value of negative 91 and make that a negative. So then you put the negative on there first and then you got rid of the absolutes, or did you?
Oh, you could do either one.
Yeah?
Yeah. Showing your work, either one would be fine. Getting rid of the minus inside first, then throwing the extra minus, or vice versa. Yeah, I put it first, you're right, but you don't have to. I think any teacher would be fine with either one. All right, good. Okay, so negative 17, negative 20. They want me to put the greater than, less than kind of symbol. Now, that's a little tricky when they're both negative like that. You know what I think would be easiest and most helpful? Be the number line. Like if zero's here, and you know the positive numbers are over here, like positive 1, positive 2, etc., huh? If you go to the left side, here's negative 17, and here's negative 20. It's even more negative, huh? I mean, they're out of proportion, but you get the idea, right? So, so which one's actually bigger? Think about money. Think about money. You been in debt? I've been in debt. I got 5 kids. I've been in a lot of debt. Which one is a bigger? No, which one's a better financial situation? $17 in debt, negative, right? Or $20 in debt? Well, 17's a little better. You're not so much in debt, right? That's the bigger number, actually, isn't it? Because you're less in debt. So that's the bigger number. So we need to put the symbol saying the 17 is, the negative 17, I mean, is bigger. The negative 20 is, you know, even further in debt, even further in the hole, smaller. So negative 17 is the bigger one, so he gets the wide side. The bigger one gets the wide side. Is that good? So it always means further to the right on the number line. Bigger is further to the right on the number line. Okay. Okay, so negative 17, and the negative absolute value, negative 17. Let me give you a second. So I would work out that absolute value stuff. First off, always let absolute values do their thing. Remember, they get rid of the minus in between them, right? So do that. Yeah, these are going to end up equal, aren't they? Do you see that? Yeah, because so these absolute values, they're going to go, boom, they're going to get rid of the minus in between them, and then they vanish, huh? But the minus in the front's still there. And then, yeah, then they're equal, aren't they? They're the same thing. So equal is really the answer. We choose the equals option. Good? Easy enough. Get the absolute value rules down. Yeah. This one, yeah, so it's 15, and these are parentheses. So they're not going to make the minus inside vanish, are they? They're parentheses, not absolute values. So that minus inside is not going to vanish. So therefore, these two minuses are both there, and nobody's vanishing. So what do two minus signs do? They make positive. Two negatives hitting each other like that make positive, don't they? So it'll be positive, and you don't need to show the positive. It just means regular 15, huh? So in the end, they are equal, aren't they? We, again, would choose the equals option. Good? See the difference between the parentheses and the absolute value, right? Parentheses don't get rid of anything. So the two minuses both stay, and two minuses make plus, or regular 15. Okay, so absolute value, 10 minus 2. Yeah, you know what I should say? First, work out the problem inside. So first work out the, before, like, notice, don't get rid of the minus right now. Don't make that 10 plus 2 right now. Don't do that. First, right, because you might be thinking, a person might think, based on what I've said so far, oh, absolute values make that a plus. Well, not till the end. You make any minuses plus at the end. First, work out the problem. So 10 minus 2? 8. Okay, so first do that. Then, when you're all done, then, if necessary, get rid of any negative inside. So do I even have any negatives inside? No. So, but these guys do vanish, and so the answer is regular 8. Remember, they always vanish. You don't want to type them in as an answer. They always vanish at the end. So the answer is just regular 8. So really, the absolute values did nothing on that problem. They weren't even really important at all. Good to there? All is well. Okay. So the absolute value -5, absolute value 4. Okay. So go ahead, give that a try. So this is 2 separate absolute value questions, right? So the first absolute values, they get rid of the minus that's in between them, and they vanish. The second absolute values, they don't have any minus between them, so they just vanish, and then it's just 9, huh? They just add up like that. Good? Easy? Number 16. Okay. Let me write that out. So the absolute value of 9 plus 6 minus the absolute value 14 minus 12. All right, so do each of those 2 separate absolute value problems. Okay, so the first one is at 15, the other one 2. So far, so good. So you first work out the problems inside the absolute values. And then, what do the absolute values do? Well, there's nothing for them to do, huh? There's no minuses. They do not get rid of this minus that's in the middle because that's not between apps. That's not within an absolute value, right? So it's just absolute value 15 and they vanish. Absolute value 2 and then they vanish. 15 minus 2, 13 done. Just like that. Is that good? You guys thinking, this is the easiest math class I've ever taken. They always start off easy and they get a little harder, huh? All right, let's take a break then. We'll take a 10-minute break on that note. Feel free, I'll go run and get, it might take me a little bit to run and get the